Okay, so today we're going to be talking about this fundamental theorem of algebra, okay? We're starting now, okay? I don't want to start saying things if you're not paying attention. Okay, so what do you mean by fundamental theorem of algebra? Can you read this? Anyone? Okay, go ahead.
If px is a polynomial of degree n is greater than or equal to 1, then px equals 0 has exactly n roots, including multiple and complex roots.
Okay, so basically when you say fundamental theorem of algebra, we are going to determine the number of roots in your polynomial based on the degree of the polynomial, right? So for example, let's say we have p of x equals, let's say, x minus 1 squared and then x plus 4 cubed, right? We know from yesterday's lesson that the degree of this polynomial is what? 5. And it's 5. We just sum up the exponents. 2 plus 3, that's 5. So since we know that this polynomial has degree 5, and based on the fundamental theorem of algebra, we can determine the number of roots, right? Because we know whatever is the degree, n, whether n is greater than or equal to 1, then it has exactly n roots. Therefore, we can say that this one has exactly 5 roots. Okay, whatever the degree is. Okay, and that includes because sometimes when you try to graph a polynomial function, you can only see x-intercepts are less than 5. If, for example, let's say this is, you have a different function, polynomial function, and then you can only see like 3 x-intercepts, but you know that the degree is 5, therefore the other 2 are imaginary. Okay, so this 5 roots can be real or complex. Okay, complex means imaginary. You cannot see that on the graph because the only thing that you can see on the graph for the x-intercepts are real roots. Okay, so the 5 includes real and complex. All right, including multiple, because we know that a root can be repeated twice or thrice or many times, right? So if you have like x equals 1, multiplicity of 5, then we're going to count it as 5 roots. Okay? The multiplicity is included in the counting for the total. Okay? Now, also it states that p of x has at most n minus 1 turning points. So therefore, if the degree is 5, we just have to subtract it by 1 to get the number of turning points. Okay? So therefore, this is going to be 5 minus 1. Therefore, we have at most 4 turning points. Okay? At most 4 turning points in this function. In this function, x minus 1 squared times x plus 4 cubed. Okay? So what do you mean by at most? It can be, you can have 1 turning point, 2 or 3 or 4, right? But it cannot be more than 4. Okay? As long as you know the maximum number, it's 4. All right. Also, let's define this. Because sometimes on the test, you'll be asked to write your answer as a 0 or solution, or as a factor, or as an x-intercept, okay? So for example, if we have this, let's say this is our polynomial. P of x equals x squared minus 4x plus 4, written in standard form, okay? We know that we can factor this out, right? What's the factor of x squared minus 4x plus 4? Yes, -2 and -2, so I can write this as x minus 2 times x minus 2. So again, this is your standard form. Okay, the first one is your standard form, and the second one is your factored. You can also call factored form as intercept form. Okay, factored or intercept, that's the second one. Okay. Now, if you're going to express this in this way, so we say that one of the zeros, because we have x minus 2 multiplicity of 2, right? I can also write this as p of x equals x minus 2 squared, right? So the 0, 2 is repeated twice. So that's going to be bounds at x equals 2. But then if we're going to write the zeros, I can write this as x equals 2, right? So this is a 0 or solution. So remember this format. If you have x equals p, that's your form for the 0 or solution. So 0 and solution means the same thing, okay? And then if you're asked to write the final answer as a factor, then you can write this as x minus 2, right? So is a factor. And then if you're asked to write the final answer as an x-intercept, then you can write this as what? 2 comma 0, right? 2 comma 0 is the x-intercept. So make sure you know the form, okay? Because if you write it in a different format, then it's going to be wrong, right? So again, this is how we write a 0 or solution. This is the factored form, and this is the intercept form, okay? All right, so in yesterday's lesson, you're given the polynomial function in the intercept or factored form, in this form. But for today's lesson, we will be solving polynomial functions given in standard form. Okay, so make sure, that's why I did the factoring review first before this lesson, because we're going to do the factoring techniques. Okay, all right, so before we discuss this, let's go to the example. So here we're going to find all the real solutions and find a degree, the maximum number of roots and turning points, describe the end behavior of the graph of the polynomial, list the roots and multiplicity just like what we did yesterday, and then determine the behavior of the graph at the zeros. Okay, so this one is written in standard form, right? In yesterday's lesson, to find a degree given the factored form, we sum up the exponents to determine the degree. But for the degree of the standard form, it's just the highest power, right? So the degree is 3. If it's in standard form, you do not add the exponents, okay? Now, what is the leading coefficient? 1. Since we know that the highest degree term is x cubed and the coefficient of this is 1, so the leading coefficient is 1.
So we do not add the exponents.
We do not add exponents for standard form, but for intercept form, we add the exponents. Yes.
Our problem is different.
Yeah, that's
2 plus 5x.
Okay. Yeah, maybe I'm looking at the wrong. Okay, thank you for telling me that. What's yours? Oh, okay. Thank you. Hold on. Maybe I copied the wrong one. But number 2 is correct, right? Look at number 2.
Yeah, so number 2.
Number 2 is, okay. So it's just the number 1. Hold on. Is this one? Okay. Okay, so let's do it again. But it has the same degree and leading coefficient, right? Okay, so degree is 3, leading coefficient is 1, okay? And then we know this is odd positive, right? So what will be the end behavior of this polynomial? So think of this as, what is this? Increasing or decreasing graph?
It would be a negative infinity, infinity.
Okay, so increasing graph, so we start with negative infinity at the left side and positive infinity at the right. Okay, now how many roots do we have in this polynomial?
2, 3.
Okay, so since we know the degree is 3, based on the fundamental theorem of algebra, whatever is the degree, that's the number of roots you will have. Okay, so exactly 3. It can be real or imaginary. Okay, number of turning points, 2. But we say at most 2. Okay, how do we get 2? Just subtract whatever's the degree minus 1. And then at most 2, because you can also have like maybe it's going to be 1 or 2. Okay, but cannot be more than 2. And then, so for this part, this is the solving part, right? So we're going to factor this so that we can write this in the factor intercept form. Because yesterday's lesson, you're given directly the factor intercept form. So it's easier to write the zeros and multiplicity. But this one is not. So it is in standard form, so we're going to solve that on this side, okay? Now, the first thing that we're going to do, make sure we're going to express this as p of x equals 0. So we're going to write the right side of this equation. This side must be 0. So how do we do that? Subtract by 20, okay? So I can write this as x cubed plus 5x squared minus 4x minus 20 equals 0. Make sense? Okay. Now, how do we factor this? So if we have a 4-term polynomial, right? Because we have 4 terms. How do we factor a 4-term polynomial?
It would be, you would group them together. It would be x squared plus 5, x to the third plus 5x squared grouped together, and then 4x minus 20 grouped together. And then you would take the common factors out.
Mm-hmm.
So the common factor would be x to the x squared for the first one. So that would be x plus 5. And then the second one would be 4.
You're going to include the sign, so negative 4.
Negative 4, and then it would be x plus 5, and then you would group them together. So it would be x squared minus 4, and then x plus 5.
Okay.
And then set them both equal to 0.
Yes. That's right. Question? Now, but we can still factor x squared minus 4, right? That's a difference of 2 perfect squares. What's the factor of x squared minus 4? X plus 2, x minus 2. Okay. And then we're going to set this, each of the factors to 0. Yes. But then, since we're asked to write the factor intercept form on this part, so I'm just going to write p of x. That's our polynomial function. And then just copy all the factors. Okay. So you got x plus 2, x minus 2, x plus 5. Okay. So this is the factor form. Okay. Now again, just like what Ivy said, we're going to set each of the factors to 0 to solve for the zeros, right? So if you do that, x plus 2 equals 0, x minus 2 equals 0, x plus 5 equals 0, and then solve for x. This is negative 2, this is positive 2, this is negative 5, right? Okay, so these are the zeros. Or again, zeros or solutions are the same thing, okay? So we're going to write x equals negative 2, and then x equals 2, and then x equals negative 5. Right? Now, what is the multiplicity of all the zeros? It's just 1, because each one, negative 2, 2, and negative 5, is just repeated once. So all of this, you can just say multi of 1. So what is the behavior? What happens at the zeros? What is the behavior of the graph? Okay, yes. So pass through. Since all of them is passed through, so we can just say pass through all zeros, right? Or if you want, you can specify negative 2, 2, and negative 5. Any question? Okay, let's have another one. And then number 4 will be your practice, okay? We can do 2 and 3 for our example, and then number 4 is your practice. Number 4. We'll do 2 and 3 as a class. Okay, any questions? All right, so let's do number 2. So we're given this polynomial, 2x cubed minus 5x squared equals 3x. So what is the degree? Degree is 3. What is the leading coefficient? 2. And this is the same as what we had in the first polynomial, right? Because that's odd, positive. So that means it's going to be increasing. So this one is going to be negative infinity at the left.
Wait, it's positive because it's negative.
Only if it's even positive, okay?
Yeah, but it is.
No, the degree.
The degree is 3, not even. Okay, now remember, class, when you, okay, only if it's even, okay? Because, again, we have to know the degree, okay, if it's even or odd. So here, degree is 3, it's odd. We can only have positive if the degree is even, right? Even positive. This one is positive, yes. So it's the same as what we had in the first polynomial, right? So odd positive, so this is negative infinity, this is positive infinity. Okay? If the degree is 4, then we can do positive, okay? All right, so number of roots. How many roots do we have? Whatever is the degree, okay? We did not subtract. We only subtract if it's turning points, okay? So number of roots, exactly 3. And the number of turning points, at most 2. It can be 1, but we know it should be at most 2.
How do you know that? Can you explain that again?
The number of turning points, we always, whatever's the degree, minus 1. Based on the fundamental theorem of algebra. Whatever's the degree, minus 1. Okay? All right, so, and then this is the solving part. So we're going to solve for the factors. So we can write this polynomial in the factored or intercept form. Okay? So, how do we write this in standard form? This is 2x cubed minus 5x squared minus 3x equals 0. So this is your standard form. Always write this as p of x equals 0. Okay? Now, so we're going to factor this. This is a trinomial. So we can factor this using the AC method, right? Think of 2 numbers. But then if we can still factor by taking out the GCF, we have to do that first, right? Can we factor out a common factor? X, yes. Because 2x cubed, 5x squared, and 3x has a common factor, which is x. So we're going to factor out the x and then divide all of these by x. So that's going to be 2x squared, right? And then minus 5x, and then minus 3, and then equals 0. Make sense? Okay. So now, what we do is, we're going to factor 2x squared minus 5x minus 3. Now, remember that the coefficient of the leading term is not 1. It's more than 1. It's 2. So what we do here is not just think of 2 numbers and multiplies to negative 3 that adds to negative 5. No, we cannot do that. Because we have to consider that the coefficient of the first term is more than 1. So therefore, what we do is we're going to create a 4-term polynomial. Right? Okay. So how to do that? We just have to do AC, right? A times C. So that's A is 2, C is negative 3. So that's negative 6. So instead of negative 3, we're going to use negative 6. Okay? So we think of 2 numbers that multiplies negative 6 and adds to the middle term. The middle term is negative 5. So it should add to negative 5. Right? Negative 6 and? Yeah, negative 6 and 1. Okay, 1 is negative, the other is positive. Question? Okay, so we know negative 6 and 1. Okay, so what we do here is I'm going to rewrite this trinomial to a 4-term polynomial using negative 6 and 1. Okay, we're going to bring down the x later on. Just write that in the final answer. But then for this part, I'm going to write this as 2x squared minus 6x plus x minus 3. equals 0. Okay, how did I get negative 6x plus
How
x?
do you know which one to do for where? Like, how do you know to put 6x before x?
It doesn't matter. It doesn't matter. Well, you can put the x first and then the negative 6x to the second. It's going to give you the same answer. Okay? Because you will factor both groups. Okay? So it doesn't matter which one you put first. But then sometimes there are types of functions wherein you have to make sure that you can find a common factor when you put this in. Okay? All right. Okay, so again, I can group this and then group this and then factor each group, right? So how do you factor that? Okay, 2x. So I can write this as x minus 3. And then this one, the common factor is just 1, right? And then x minus 3. So you will know if your factors are correct if these are the same, right? The one inside the parentheses is the same. So how do you write this now? That's 2x plus 1. So 2x plus 1 and then x minus 3. But do not forget the x in your GCF. That's your first factor. Then equals 0. So these are the factors now. Okay? So you can write this as p of x equals x times 2x plus 1 times x minus 3. Okay? Now, so what are the zeros and multiplicity of the zeros? So we know if we set x to 0, then x equals 0. If we set 2x plus 1 equals 0, what's the value of x? 2x plus 1. If we set this to 0, 2x plus 1, negative 1/2, yes. So subtract by 1, and then that's 2x equals negative 1, and then divide by 2, so negative 1/2. Right. So this x is equal to negative 1/2 if we got 2x plus 1 as a factor. And then what's the last one? Positive 3. Okay, x equals 3. Now, what is the multiplicity of all? It's just going to be 1, right? Because all of the zeros just repeated once. And we know that the total number of roots is 3. So if we're going to add this 1, 2, 3. Okay? So multiplicity of 1. And so we say pass through all zeros. Any question? Okay, so last example. Last example for the notes. All right, so this one is the same thing, right? Because the degree is what? 3. We got 4x cubed minus 12x squared minus 40x equals 0, so degree is 3. The leading coefficient is 4, so it's also odd positive. And so at the left side, it goes down, it falls. And at the right side, it goes up, it rises, so it goes to positive infinity. All right, so again, think of this as that, right? So negative infinity at the left, positive infinity at the right. Okay, so how many roots do we have here? We also have 3, or I just say exactly 3. And then how many turning points do we have? At most 2. And then we're going to do the intercept form. Okay, so if we solve this, this is already in standard form, so we just have to factor out the greatest common factor, right? So this is 4x cubed minus 12x squared minus 40x equals 0. So what is the GCF? 4x. Correct, 4x. Okay, we can divide 4, 12, and 40 by 4, and then the variable by x. So 4x. And then just divide all of that by 4x. So 4x cubed divided by 4x is x squared. Negative 12x squared divided by 4x. Negative 3x. And then negative 40x divided by 4x. Negative 10 equals 0. Now this time we know that the coefficient of x squared, the leading term, is only 1. So we can just go ahead and do this. Take up two numbers and multiplies negative 10. The sum is negative 3. What's the sign of 5? Negative? Yeah, negative 5 and 2. Yes. So that's negative 5 times 2 equals negative 10. And then if you add this, the sum is negative 3. So I can write this. You're going to bring down the 4x here. So 4x. Then you can write this as x minus 5 and x plus 2. We don't do the grouping if it's the leading coefficient of the first term is just 1, right? Equals 0. Okay, so these are the factors. So you can write this as p of x equals 4x times x minus 5 times x plus 2. All right, and then we know, so if it's 4x, what is going to be the 0 here? If you set 4x to 0,
Negative 4.
will it going to be negative 4?
Yeah, negative 4. Oh, wait, no.
Yeah, it's just 0, right? If you divide 4 on both sides. So therefore, x is 0, and then x is 5, and x is negative 2. So these are your 3 zeros. And again, it's just repeated once. So all of this is multi of 1. And so pass through. Any question?
Where did you get the x equals 0 from?
From the 4x. Yes. So if you set, remember you set each factor to 0. So if you set 4x equals 0 and solve for x, you divide by 4. 0 divided by 4 is 0. Any questions? All right, so I want you to try number 4.